Hi, I'm Bianca Bertolino and this is Lab 5 for Physics 2211. The purpose for this lab was basically create our own model based on the methods learned in lab along the semester and apply it to the experiment. And since I play volleyball here at Tech, I decided to do my project around that, and it's based on the motion of a serve in a volleyball court, and I created my model using GlowScript for coding. The fundamental physical principles that I used were the same as the first lab. First, I used the Newton's second law formula, then I used the momentum update formula, and finally the velocity update formula. So for my code, I first set up gravity as 9.8, and basically my code is making a volleyball court and simulating someone serving and see what happens when the force of that serve is bigger or it's smaller. So I set the court length, the court height, and all the measurements are the actual measurements in a real volleyball court. I also define the court and the net, and I set up the initial conditions as the height at which the serve will go, the angle at which the serve will go, and the force. And changing the force will make the serve go under the net, out of the bounds, or over the net basically, but I will show it later. I also set up the ball parameters with the actual radius of a volleyball court, of a volleyball, and I also use the equations here that I mentioned before, and the conditions for landing that my program will tell me whether the ball it's out, it's on the net, or it's a point basically. So here is what happens when I run the code. I started by first using a force of 10 meters per second, so it's basically the velocity. So this is what happens when the velocity is 10 meters per second. The ball will be on the enemy's court basically, so it will be a good serve. That's why we call it volleyball. Then I change the velocity to be 8.4, and when the program is run, the ball doesn't even get to the net, so it lands on our own court basically. Then I changed the velocity to 9.2, and the ball ended up landing on the net. And finally, I set it up to 13 meters per second, and the result was the ball going out basically, but making it over the net. And for my questions, the question that I asked is, what effect does including air resistance have on my predictions? Well, in the computational model, there is no air resistance, so the ball can travel further because there is nothing stopping the ball. And there is also other factors. There are other factors that affect how the ball is gonna go over the net or not. For example, like the way of hitting the ball. If we use our hand flat, the ball is gonna travel further. But if we do it with a different spin, like the ball sometimes ends up in a different position. Thanks for watching.